Okay, so we're going to talk here a bit about combining like terms. We talked about it yesterday. We're going to use the images in polynomials to define like and unlike terms. Now, here we have each of these expressions are combined, made up of unlike terms. We all have different exponents, different variables. We can compare, however, these and this would be considered like terms. This and this will be considered like terms. Now, if we're assuming that these are negative x squared, and x squared, then this as well would be a like term. And we also, because we know that these are units, this would be a like term and that would be a like term as well. With the other variable strips, it's hard to kind of compare because these are all different variables. I think they made a mistake on this sheet. I think they should actually be all x's. It would be easier to compare. So we're going to just disregard, because this top part is kind of making me it's not very useful. But we're going to talk about what makes like and unlike terms. So like terms have the same variable bases and corresponding exponents. And that is the root of it, really. So things we can look for constants. All constants are like terms. Look for only squared variables. X squared, whether you have 3x squared, minus 7x squared, 13x squared, they're going to all be like terms. Look for variables with no exponents. So 3a, 14a, minus 2a, those are all like terms, okay? With unlike terms, look for different exponents. And different variables. Okay, so really pay attention to the exponents. Okay, all right, now that's kind of wordy there. We can do some examples that might help us. So here would be some like terms, and I'm going to do them in different colors. So we might have 2x, negative 3x, 14x. Those are all like terms. And the nice thing is we can collect them up and combine them. Okay, if I had xy, 3xy, negative 7xy, those are all like terms. The variable is the same. All right. I'm just going to put some little bullets here for this. If I have some constants, so I have 14, 23, negative 1, negative 7, those are all like terms. And then finally, if I have 12x squared, 2x squared, so you see they're all x squareds, negative 3x squared, those are all like terms. Okay, so the different colors identify what they are. And what that means is that it means they're all the same size and shape. That if I change the value for x in one, I'd have to change the value in x for all of them. Okay, and I can combine them. So we can combine like terms. Now we're going to look at combining pictorially and symbolically. So here I've got my algebra tiles, and when we combine them symbolically, basically what we're doing is we're going to gather up opposites and make zero pairs. So here I've got two x squareds, I've got a negative x squared, I've got a couple of x's, and I've got some unit pieces. So what I want to do is I want to pair up opposites, right? Because this is an x squared and a negative x squared. So if I have an x squared and I take an x squared away, they equal 0, right? X squared minus x squared equals 0. So they would cancel out. And here I can match these two out. These are just numbers. So if I have a negative 1 plus a 1, it also equals 0. So they cancel out. So if I think about that, basically they would cancel each other out. So then what I have left is the remainder of the expression. So here I have an x squared, I have two x's, and I have negative 1, 2, 3, 4, 5. And that would be my solution. Okay? Now, if I'm looking at this in terms of what do I have symbolically, well, like I said, I had two x squareds, right? I have a negative x squared. So I'm going back to the original pictures. I have two x's, I have negative 6, and I have a plus 1. Okay? That's what's in the picture. If I combine my like terms and deal with them like so, I can add and subtract them. So here I would have 2x squared minus an x squared. So I have 2 take away 1, so I just have x squared. I only have the 1, 2x, and then I have negative 5. So I get the same answer. Okay, remember you just can only add and subtract them if they're exactly the same shape. Okay, so take a look there, if you want to take a screenshot. All right, so let's do this next one. I'm looking for pairs. So I have those two cancel out, and two of these cancel out, and those cancel out. So once I do those, if I think about these as being gone, because they add up to 0, all I'm left with what's left over. So what's left over is negative 2x, right? This is what I have these, and I have these, plus 2, and that would be my answer. Now if I wanted to do this symbolically, I can list all the things I have. I have an x squared minus an x squared, minus 4x plus 2x plus 3 minus 1. And again, sometimes it's easy to kind of circle what you have, group the like terms, and sort them out that way. So x squared minus x squared, well, anything take away itself equals 0, right? So that would be a 0. Then negative 4x plus 2x, so I have negative 2x. And then 3 minus 1, so I have 2. Now I don't write that 0, so I just write negative 2x plus 2. Okay? All right. Do another couple of examples here just to kind of reinforce this. And as I said, you can use any method. If you look at it and you go, Miss, I hate the algebra tile way, then don't do the algebra tile. Do the other way. I'm not going to dictate your method. Okay? So here, these two will cancel each other out. These two will these 6 will cancel each other out, and those will cancel each other out. So then it's just a matter of what do I have left. I have a negative 3x squareds, because I have negative x squared, and negative x squared. I have this one here, so plus x, and then I have minus 6. Okay, so it's just collecting, right? Because this goes away, and those go away because they cancel each other out. All right, let's look over here. If we write this out in total, I have negative 4x squared plus x squared. That's my big x squared blocks. I have negative 3x plus 4x, and then I have negative 9 plus 3. Okay, so let's combine those like terms. Negative 4x squared plus x squared gives me negative 3x squared. Negative 3x plus 4 gives me x, and negative 9 plus 3 gives me, did I do that wrong? Yeah, no, negative 6. That is correct. I'm sorry, I got distracted. I'm going to just write that prettier because that 6 looks a little wonky. Okay, and you can do that in steps. I've done that. I did it all in one step, and that's fine, right? You just need to make sure that you kind of keep each section straight. Okay, so when we have values that are greater than a square, we cannot use algebra tiles. Okay, so we're going to look at this one. This one has a 2p to the 5. We can still gather them, but we can only do it symbolically. So here, what I want to do is I'm going to group things according to their exponents. I'm going to put it in standard form, so I'm going to rearrange this into standard form. So the first, the highest we have is 2p5, right? And then I have plus 5p squared. Then I get negative 4p, negative 6. Oops, I missed one. See, and sometimes that happens. So let me just delete this. I forgot this p squared there. Minus p squared, then minus 4p, minus 6p, plus 8, plus 3. I think I got everything. Hopefully I did. But I put it in order because then when I do that, it's easier to group things, right? Because I can group those two together, those two together, and those two together, and it'll be easier for combining. Okay, so my 2p to the 5, that stays as is. 5p squared minus p squared leaves me with 4p squared. Negative 4p minus 6p is negative 10p, and then 8 plus 3 is 11. Okay, I do like reordering it, so put in standard form first, because then it's going to be in the right order and it's easier to sort things out. Okay, so that is the notes for this. Now it's time for you to do some practice. So you're going to finish the rest of this worksheet practicing simplifying polynomials. I will post the key for you for your practice. And hopefully this is starting to make a little more sense.